Okay, example 2. Calculate the product moment correlation coefficient. Anybody, which classes taught by Mr. Ho? Okay. Mr. Ho will stress, it's not correlation, it's correlation.
He always stress like this must be correct. I also must learn. I educated overseas, of course better. I NUS. Yeah. Okay. Anyway,
Anyway, I'm a civil engineer by training. I'm not a math graduate now. Wow. And that means I'm not actually very qualified, you know. You scared, huh? Scared, right? Too bad, I already lectured, almost finished. Scared also no point. No use. Okay? Never mind, it's okay. Never mind. I a bit better. Not better. I took F math when I was a student. Okay? Yeah. No, actually, everybody, a lot of teachers also did when they were students. Alright?
Yeah. And I took last time is
no time, we cannot tell story. Okay. But we are supposed to calculate the R for the data in example 1. Where's example 1? Let us see, okay? Example 1 is here. Let's see, okay? Example 1, where? Here. Okay? That means you got all these. Alright, are we able to calculate the R from here? Actually, the outline is given. How do we do it? You just enter L1, L2 here. Okay, then you step 4 steps. Then you choose linear regression AX plus B, and then you will get this R out. Okay, we shall do it together. Need or not? I think no need, you'll do lah. But I just want to emphasize this, okay? Yeah, it's just ours. Okay. Very quickly lah, you all do, okay? You all do too, okay? 30, 45. You all should have the data inside, right? Then you all should be faster than me. Just follow the steps, okay? Three, 3.1, 1.5, 3.7. No, wait. 2.9, 3.1, 3.5, 1.5, 3.7, and 2.8. If you notice, if you go to calculate, actually, there is this linear regression AX plus B, or linear regression A plus BX. Actually, they are the same thing. Whichever one you choose doesn't really matter. Later I explain. Okay, for now we just choose 4. It really doesn't matter. Alright, your X list is L1, Y list is L2. Then you calculate. Wait, how come don't have? I know what to do. The step diagnostic should be turned on. Actually, by right, yours should be turned on. Okay? You should see your R. Okay? Then you should get R, 0.917. Okay? Done. So, 0.917. Okay? Can? Copy? 0.917. What does it suggest? The question need us to comment on its value. You see, 917 close to 1. We should comment that there could be a strong linear positive correlation. There are a few words important, okay? And later I let you copy, but I just want to emphasize. You should say strong because it's close to 1. You should say positive because it's a positive number, upward sloping. You should say linear because R only measures linear relationship. three important words. Okay, then after that you conclude in context. Okay? So you should say strong, positive, linear. Three words are very important. Okay? Alright? Okay, B. You are given the summarized data, summation x, summation y, summation x squared, summation y squared, summation xy, and number of terms n. I think we all know what all this means, but just to give us an example, what is summation xy? That means actually you are given data sets, right? For example, in example 1, you are given like 32.9 as a ordered pair, 40, say 45, and 3.0. This is example 1 data. Summation xy essentially means that you take x, the x1 times the y1, multiply together, you got one value. X2 times y2 another value, then you sum all the 30 up. Okay? That's all lah. Basically, that's what it means. They give you the summarized data. How are you going to make use of this summarized data to calculate the product moment correlation coefficient? Just use formula lor. Here, just substitute. Quite brainless actually. Okay, you just substitute the xy, summation xy as this is 24844. Then this one substitute, you get 680. This one is 996. Correct? Then this one is 30. Correct? You just dump all the values in. Your final value should be 0.823. This one go back and try. Okay, I'm not going to spend too much time. Okay? You just substitute suitable the appropriate values and we get the answer. Just an important note, the R is only a measure of linear correlation. Okay? You cannot just believe the R alone. What do I mean? Example 3 will tell us. Okay, example 3 will tell us. Especially 3.5b. Never mind, let's do example 3. For each of the bivariate data, find the product moment correlation coefficient, draw a scatter diagram, and then briefly comment on your value of R. Wow, so many things. Never mind, we'll do it. Okay, we cut the story short. We can easily do this, and then you realize that R is 0. That means enter this A data in. Don't need to key in, I just do it for you, okay? Then you realize that R is 0. Now, R is 0 suggests that there's no linear correlation. Fine. But what do they need a little bit more? They do need you to comment more on the value of R, and then you're supposed to draw a scatter diagram, draw a scatter diagram. So let's draw a scatter diagram. That means you are supposed to plot lah. Actually, this one don't need GC to help us, right? You have -2, 4, you have 1 point here. -1, 1, you have another point here. Correct? Then you have 0, 0 is another point here. 1, 1 is another point here. 2, 4 is another point here. This is your scatter diagram. Done. You either mark it with a dot or cross. Actually cross is okay lah. Dot is also fine. Just do a bigger dot. Now you realize that even though R is 0 and there's no linear correlation, you realize that the points actually lie on the curve y equals to x squared. So you cannot say that there's no relationship. It's just that there's no linear relationship. Follow? Because R is 0, and you say, oh, scatter diagram also suggests that there's no linear relationship. But there is a relationship. It seems that there is a quadratic relationship. So that's to tell you that actually R only measures linear correlation. Next thing. Part B. So now B, now we have data again. We have data again. I don't want to enter this into my GC. You all can do it. Okay? Or actually, you all don't need to do it. Okay? Pretend we do it. Okay? Pretend we do it and pretend that we get this value. Okay? Pretend that we get 0.862. Okay? We pretend. Okay? Cut short the process. This suggests that there is a strong positive correlation. Correct? Because it's close to 1. Fair enough? Fair, right? Fair conclusion. But remember what I said earlier here, just before example 3, I say that you should also consider the value of R in conjunction with a scatter diagram. Example 3 asks us to draw a scatter diagram. So we draw. This one also no need GC to help us. We can actually do it. Let's try, okay? Let's do this, okay? 1, 1, I have a point here. Correct? 1, 2, I have another point here. 1, 3, I have another point here. Correct? Now 2, 1, I have another point. 2, 2, 2, 3. 3, 1, 3, 2, and 3, 3. I've plotted all the points all the way until here, 3, 3. Follow so far? Then we have a last point, 9, 8. All the way at the end. Okay. Now what happens is this. You got all the points there, you try and calculate mathematically what's the value of R, you get a value very close to 1. Then you say, oh, I think there's indication of a strong positive correlation, linear correlation. But look carefully. If you take that last point out, then the cluster of 9 points actually has no correlation, doesn't suggest that there's any correlation. That point is called an outlier. Outlier can happen for a variety of reasons. When you conduct experiment, sometimes what happens, you see wrongly. Correct? Or you accidentally add a little bit more chemical, when actually you should add a different amount. Correct? So sometimes this happens because of mistake. This cannot really be fully trusted. Like I say, but if you put this in and calculate the R value, it artificially distorts the value of R such that it's close to 1. Somehow, mathematically. Because it's so far away, then when it seems like there is a linear relationship, it seems like. But if you take this point out, then there's nothing. So, what I'm trying to say is, this outlier it distorts the value of R. We cannot just trust our value 0.862 so at face value. For what I'm saying, if you just trust 0.862 at face value, you would then say that there's a positive linear correlation. But if you look at the scatter diagram, then you must be very cautious. For what I'm saying, you must be very cautious. Okay? Enough of that. So, I want to emphasize this. Okay, the value of R close to 1 or minus 1 does not necessarily imply. You must always check by referring to a scatter diagram. Okay?